So in this video we're going to learn about blood glucose levels and diabetes. We need to know about the effect of chronically elevated blood glucose levels. A normal blood glucose level is around 5 millimoles per litre of blood. A person who suffers from untreated diabetes may experience chronic high blood glucose levels of up to 30 millimoles per litre. Chronic means that the blood glucose levels are raised for a long period of time. So chronically elevated blood glucose levels mean that the endothelial cells lining the blood vessels take in more glucose than they would normally do. This damages the endothelium and damages the blood vessels. High levels of blood glucose then cause this damage to the endothelium. That then increases the rate at which atherosclerosis takes place. We learned previously that atherosclerosis starts to happen after damage to the endothelium. So high blood glucose levels cause damage to the endothelium and cause the cholesterol to accumulate under the endothelium, leading to cardiovascular disease, strokes, heart attacks, etc. Because the tiny capillaries are made up of just an endothelium, damage to that endothelium may result in hemorrhages in places like the retina. If it happens in the kidney, it can contribute to renal failure. It can also cause nerve dysfunction, resulting in loss of feeling in pins and needles. We also need to be able to describe how the receptor cells in the pancreas and hormones are involved in the negative feedback control of blood glucose. All the cells in your body need glucose to carry out respiration. However, the glucose in the blood must be kept within strict limits. There are hormones involved in maintaining a constant blood glucose level. Glycogen is how our bodies store excess glucose, and glycogen is stored in the liver. After eating a meal, the glucose in your bloodstream is converted into glycogen in your liver. The glycogen is then stored until it's needed. When your blood glucose level rises after eating a meal, this increase in blood glucose is detected by receptor cells in the pancreas. The pancreas then produces the hormone insulin. Insulin is a hormone that decreases the blood glucose level. Glucagon does the opposite. It increases your blood glucose levels. The hormones are said to be antagonistic to each other. They have opposing effects on blood glucose levels. The pancreas has got clusters of endocrine cells that produce glucagon and insulin. And you can see these here in the diagram, right? There are cells, a cluster of cells in the pancreas called the islets of Langerhans. You don't need to remember that name. And you have some that secrete insulin, and you have some that secrete glucagon. So insulin is the hormone that stimulates the conversion of glucose to glycogen. So insulin will decrease your blood glucose levels. Glucagon is the hormone that stimulates the conversion of glycogen to glucose. So glucagon increases your blood glucose levels. And blood glucose levels are detected by receptor cells in the pancreas. So these pancreatic receptor cells respond to raised blood glucose by increasing insulin secretion. They then convert or stimulate the conversion of glucose to glycogen in the liver. That will then decrease your blood glucose levels. If your blood glucose levels fall too low, the pancreatic receptors will detect this. They will increase their secretion of glucagon, and glucagon will stimulate the conversion of glycogen to glucose in the liver, and that will increase the blood glucose concentration. And this diagram just summarises that. So this process is referred to as negative feedback control, and it's something we came across previously when we were looking at the reproductive hormones. Negative feedback control means that if you want things to stay the same within set limits, any change must be corrected. So with respect to blood glucose level, if your blood glucose level rises, for example, after a carbohydrate-rich meal, that is the stimulus that causes the pancreas to release insulin into the blood. The insulin then causes the liver to convert glucose to glycogen. That means the blood glucose level declines and the blood glucose level will return to its normal set limits. If the stimulus means that the blood glucose level falls, for example, if you've skipped a meal or done some exercise, that will stimulate the cells of the pancreas to release glucagon into the blood. Glucagon stimulates the liver to break down glycogen and release glucose into the blood, and that causes the blood glucose levels to rise and return to within normal limits. Adrenaline also has a role to play in helping to control blood glucose levels. During exercise and fight or flight responses, adrenaline increases glucose levels in the blood. Adrenaline is released from the adrenal glands, which sit just on top of the kidneys. So adrenaline overrides the normal blood glucose control mechanisms. It works in two ways. It inhibits the secretion of insulin and stimulates the secretion of glucagon. That then promotes the rapid breakdown of glycogen into glucose. Then, when the emergency situation is over, the normal control of blood glucose level returns.